start with machine. Whenever we say machine, to our concept, it comes to be a very combination of the different type of instruments. Okay, and maybe a very complicated one. Say the engine of a car you can consider, or you can consider even your train engine. Okay, or you have the machineries which are in the factories and other places. Okay, so the first thing which comes to our mind, the first image which comes to our mind is of a very complicated one. But actually, machine is not a very complicated machine. The machine, the examples which I had given you just now, those are the examples of the complex machines. Basically, a complex machine is a combination of several simple machines. Okay, so what does a machine do? Okay, how we define a term machine? For a layman, or in a simple term, in a very simple term, without going to any technical details or scientific details, we can say that machine, we can define it by the purpose which it solves. The very purpose of a machine is that it is a device or an instrument which makes our work easier. So anything which makes our work easier is called as machine. You might have remembered the definition given by Amir Khan in Three Idiots. Okay, anything which can make our work easier. So you are writing with a pen, that is a machine because it makes our work easier. Okay, you also have a complicated definition given in that movie. So for the time being, that happens to be right definition, but still the thing what we are able to understand should be given. So now if we try to define machine, now this was a simple term, in a simple example or simple layman style, we can say that any instrument or device which makes our work easier is called as a machine. But to understand it in a broad way, what we have to do is we have to understand the function of machine. Okay, what are the major functions which a machine, which we use, or which we are required, okay, where we use the machine. Okay, so the function and the use of simple machine. So if we try to understand, the functions of machine or use of machine, then we will be able to define machine in a better way. Okay, so the first function for which we use machine, okay, say for example you have a can which has got a lid and you want to open it. Okay, the lid is tightly pressed into the can and you want to open it. So what you have to do, you are trying to apply your hand, your fingers, but the grooves are very narrow where you are not able to fit your fingers. So what you do, you take a spoon or a metal piece, okay, put it at insert it in the grooves under the lid, and then you press it at a certain point, you'll find that it will get open. Okay, so here we have got two cases. Say for example, this is a can with a groove. So here directly if we are trying to apply, we will not be able to open it, or it will be difficult to open. It's not like we cannot open it, but it will be difficult to open. So what we do, we take a spoon or a metal piece we insert it at one point, and then we apply a force, or what we call it as effort. We apply our effort, and we find that the lid of the can will open. So we find that the lid of the can will open itself. Okay. So what happened? It's just a simple strip of metal, a simple spoon. But here it is acting as a machine. Okay. Now what it is doing? It's basically doing two things. One is that it is changing the direction of application of force. Pulling it up is very difficult as compared to applying a force outward. Okay. Earlier when we are applying a force over here on the sides, we have to apply the effort in the upward direction. Now the fingers are also not able to insert the force properly, therefore this was not opening. Okay. So applying a force over here is going to create a problem. So what it is doing, it is making the point of application of the force at some convenient position. So here it is more easier to apply a force as compared to this point. Not only this, it is also changing the direction of application of force. Earlier we have to apply it in upper direction. Here we are applying it in a lower direction. So it is also changing the direction of application of force. So here what we can make out is that the function of machine we can first is that to apply the force at a more convenient place, to apply the force in more convenient place, or you can also say that changing the point of application, or this we can also say that changing the point of application of effort to a convenient point. To a convenient point. This is the first function which a machine is required to do. Now this was one example. In this case, you can also see the example of cycling. When you are cycling, you apply the force on the pedal, and the pedal in turn is been connected through the chain to the rear wheel, and that is how it is now. Applying the force on the rear wheel is difficult. So what we do is we are applying the force on the pedal. So what we are doing, we are changing the position of the application of the effort to a convenient position. And not only it is a convenient position, but also to a convenient direction that we will be writing down in the next point. first function to apply the force in a more convenient place or to change the direct point of application of effort to a convenient point. We come, okay, that is to change the direction of the force applied. The next of force applied. As we have seen that earlier when we were trying to open the lead can, we have to apply the force in upward direction, which was not convenient to apply also. But when we were using the spoon or a metal strip, we have to apply the force in downward direction, that also away from the grooves, and hence we were able to apply it in a more convenient or in a more better way. That is why another function of machine is to change the direction of the force applied. Then we have the third function. Third and one of the major function of the machine is that quite often, suppose if I have to lift a box is say 20 kg or a sack of rice, if it is 20 kg. Now 20 kg I can lift, but I have to apply a lot of energy. All right, I have to do a lot of work in that case. In a simple term, I have to apply a lot of effort into that. Okay, so to lift this load of 20 kgf, okay, we have to apply a greater effort. Now, the same thing I can use. What I can do is, I can use a plank. So, apply the force and it will get lifted up. Similarly, another example you can have that pulling water from the well. Okay, I don't know how many of you have seen or used to take out the water from the well. Now taking the water from the well, what we have to do is we tie the rope to the bucket and then we throw it into the well and then we try to pull through the bucket water using the rope. Now when you are trying to pull this, okay, there are two ways. One is that you directly pull the bucket using the rope. This is the rope, and you are directly pulling the rope. Okay. Now here when you are applying the effort of water, okay, so you are applying an effort in upward direction. You find that you will be difficult for you to lift directly. So sometimes what we use a pulley. That is also changing the direction. Similarly, as I told you, if you have to lift, say you have to change the wheel of your car. Lift, but you cannot hold it to change the tire. So what we use? We use jack. Now, using a jack, if you have used the jack, it is very simple. Okay, you just have to put the jack just under the axle and then you rotate the jack and the jack will open. Okay, jack is of this shape. Different jacks are of different shape, but a simple jack you can say. Okay, so here what you have a knob which you turn, and here you have an range, and you will find that as you unwind the jack, this will lift. Now, as this portion rises up, you will find that it will also lift the car. So this becomes easier for us to lift a car. Okay. Similarly, we can use a spade to turn the soil. Spade means kurpi. Okay. We can use a pulley. You might have seen in the shipyards or where we get loading and unloading of the goods. Okay, huge containers. They cannot be lifted by the simple human effort. So they use the cranes. In cranes we have pulleys. Okay, so we find that it is easier to lift through them. Even nowadays, lot of construction work going on. Okay, and especially if you see for the drainage system, earlier entire of the city was under that. So everywhere it was being dug up and then huge drainage pipes have to be put inside. So what they are doing, they are just using the crane and they are using it to put those pipes into the trench which has been dug. Now, what are these examples? These examples are basically showing you that you are applying a lesser effort, okay, but are able to do a greater work. In other words, machines can be utilized to multiply your effort without you being multiplying it. Okay, so you can say that machines, one of the major application of machine is to multiply force. Like force. Force here is your effort. You don't have to apply. You are applying whatever effort you are going to. Okay, but the machine you will find that it is applied or it is being used in such a way that it is able to lift a load which is much heavier than the effort you are applying. And therefore, this is also called, this function is also called as that the machine is used as a force multiplier. Okay, examples I told you: the jack to lift the car, crowbar to use the lift heavy weight. Okay, wheelbarrow is used to carry the load. Then pulley is being used to lift the heavy load. These all are examples where it is, this machine is being used as a force multiplier. And then there are some machines which do not act as a force multiplier, which do not change the direction of application of effort, but they have been used. And they are used because they multiply the speed. Speed. That is speed multiplier. Now what do we mean by saying this? I'll give you the notes, okay? If you are able to note down something from here, you note down, otherwise I'll give you the notes as usual. Now examples for the speed multiplier is here a pair of scissors to cut the cloth, knife. We are using knife for the chopping purpose. Okay. Now, how do these act as a speed multiplier and how they are being used to increase or gain in speed? Now, if you try to observe the scissor has got two parts. In the center is your fulcrum. The front portion is your blade and back portion is your handle. Okay, if I can draw it, not exact scissor I will be able to draw, but okay, still. somewhat like this it has. So please bear with it. Okay. Now, this is a sort of scissor. Now what happens? This portion is your blade portion. These are your blade part. And this is your handle part. Now, what we are trying to do is, we apply the effort through the handle part. Now, handle part, the distance is fixed. Whatever distance to distance you are trying to apply, you apply the effort over here. Now, what happens? The blade is able to cut from here till here. If it is a sharp scissor, okay, it's not like it is an old scissor and it has got the sharp edge only at one point. But I am considering that it is a new scissor, sharp scissor, whose entire blade is capable of cutting. So just by applying the effort at this point, what we are able to do, we are able to cut a larger distance. So distance moved will be more, applying a lesser distance within the same time. So here, if I consider the distance moved is DE, and here distance moved is DL. So what we can make out, DL is greater than DE for the same time T. So speed will be your DL by T towards this side, and towards effort side it will be DE by T. So what you find, since the time for both of them, because you are applying the force at the same time and both the portion, that is the handle as well as the blades, both the part move simultaneously, so they will be covering up the same distance, the same time. So now since DL is greater than DE, therefore what we find, DL by DT will be greater than DE by DT, which means that D by T gives us the speed. Okay, speed in the effort part, load part will be greater than the speed in effort part. So what happened? The speed in the effort part, so what it is doing, it is not basically changing or multiplying our effort. It's basically increasing the speed, and therefore it is used as a speed multiplier. So to sum up the function of the simple machine, I quickly go through it. The first function was to change the direction of the force applied, or changing the point of application of effort to a convenient point. Second function was to multiply the force as a force multiplier. The second function was to apply the force at a more convenient place. Okay. Third was as a force multiplier, and fourth was as a speed multiplier. Okay. I hope these four functions are clear to all of you. If you have any question, you can ask through the chat. I have not started with the video, Ashutosh. To lift the bucket from the water. Okay, the water is filled inside the bucket, so the bucket becomes heavy. Now lifting it directly will be causing more effort, or rather it is more dangerous also standing at the edge of the well and pulling. As compared, if we apply a horizontal force, that becomes more easier. Therefore we are using, and also using a pulley, we will study in the later part. If we are using, say, movable pulley, we'll find that the effort which we will be applying, that becomes much less. Now here, in case of well, we are not using the movable pulley, we are basically using the fixed pulley just to change the direction. Okay, but in case of cranes and other things, we are using the movable pulleys, and that is how we are reducing the, or rather, we are applying lesser effort, and it is getting multiplied, and hence it is called as your force multiplier. How does the jack work such that it reduces the effort? Again, in case of a jack, you will find its construction is in such a way that when you are rotating the jack, okay, opening this, unscrewing the jack becomes more easier, and when you are unscrewing it, it will be lifting up the car. Okay, now you are unscrewing it by using one rod, or sometime it is by by hydraulic means. Okay, so that becomes more easier and convenient to apply, and that is why we are jack happens to be a force multiplier shown. Connect it again. Mayank, I'll explain you why can't a machine act as a speed multiplier and force multiplier. Just a few minutes. Okay. Uh, so I hope. All right. Now, once you are aware of the function of the machines, okay, now we can put all these functions together and now we can define the machine as a device which enable us to change the direction of force, to multiply the force, to get the force applied at a convenient place, and to multiply the speed of a given body. Now keep in mind, it's not necessary that all of them are going to be acting at the same time. Basically what we have done over here is that we have combined all the functions of the machine. According to the definition which is given in your book, it says that a machine is a device by which we can either overcome a large resistive force at some point by applying a small force at a convenient point and in a desired direction, or by which we can obtain gain in speed. Okay, so the definition basically combines all the four functions. Okay, so now it was asked also, and it has also been given. We have seen that there are various functions of the machine, out of which there are two major functions, that is your force multiplier and the second is your speed multiplier. Okay, now a machine cannot act as a force multiplier and speed multiplier both. Okay, it can only act either as a force multiplier or as a speed multiplier. Okay, the reason as it says that machine can, now when we are talking about force multiplier means load is greater than effort. All right, but speed multiplier means load is less than effort. Okay, which means that in case of force multiplier we are applying lesser effort and it is getting multiplied. On the other hand, in case of speed multiplier, it is the effort is more but the load comes less. Okay, the load becomes less. Now same machine cannot have greater than and less than simultaneously. Okay, as the machine cannot have less than and greater than simultaneously, it cannot be chota bhi or bada bhi. It cannot be small also and big also. Load cannot be at the same time simultaneously. It cannot be lesser than effort and greater than effort. Okay, this is practically impossible. Ideally also it is impossible. Okay, so therefore all can take place except these. Okay, force multiplier, if a machine is acting as a force multiplier, then it will not be acting as a speed multiplier. If a machine is acting as a speed multiplier, then it won't be acting as a force multiplier. This will become more clear when we come to the various machines and the various terms which we are associated with the machines. Okay, so I hope this is clear, and if it is not clear, wait for some more time, we'll make it more clear. Okay. Now we come to some technical terms related to the machine. Keep it in mind. We are going to be using various terms now. For example, now only when we are using it, I'm using the term force, but I'm also using a word effort and load. Because if you talk about force, now force is a very common term. Okay, we have numerous type of force. So depending upon its application, depending upon where we are using it, we are terming this force or naming this force by the different names. For example, if we are talking about the friction, we call it as the frictional force. If we are talking the electric field, electrical force, magnetic field, magnetic force. Similarly, here when we are talking in terms of the load and effort. Keep in mind. So we start with the terms related to machine. So terms related to machine. The first term, that is load. As per the definition, the load is the resistive or opposing force to be overcome by machine. Resistive or opposing force. Force to be overcome by machine. This is denoted by L. So always you will find it will be denoted by L. Some places it might be denoted by W also. Some books you might find it by the letter W also. That is weight. So load is nothing but your weight of the body. Okay, which has to be lifted. Say if I lift a box, the weight of the box will be called as the load. Okay, so it might be denoted as L, it might be denoted as W. In your book, that is in Selena, it is denoted by L. And in your boards also, we are using the same. The second is effort. This is the force which is applied on the machine to overcome the load. Force applied on machine to overcome the load. This is denoted by E. Okay, so the force which is applied on the machine, okay, by whatever means it is, then this is called as effort. So whatever effort, whatever force you are applying on the machine, or whatever force applied by the machine, okay, that is called as the effort. Okay, keep in mind both of them are type of force, and therefore the unit will be your units of force. Then we have mechanical advantage. We denoted by MA, capital M and capital A. As per the definition, it has been defined as the ratio between the load to the effort. Okay, or it can also be defined as the ratio between the resistance overcome to the effort applied. So it is the ratio between load and effort. That is, mathematically, we can express mechanical advantage as MA is equal to L upon if you try to find out the unit, I hope all of you will be able to make out what unit it will have. It will have no units. Okay. Now, what does this mechanical advantage gives us? Basically, the mechanical advantage, the value of mechanical advantage help us to determine what type of function we can put the machine into, or what function it can be put. Okay. So let me explain you what are the functions it can be put into. Now for mechanical advantage, as I told you, that mechanical advantage is equal to load by effort. Now there are two quantities. Now if there are two quantities, there can be three cases in this. The first case can be effort is less than load. Now if effort is less than load, which means that the ratio L by E, okay, E is smaller, L is greater. So the ratio L by E will be greater than 1. Which means that mechanical advantage is going to be greater than 1. Now try to understand. Load is more and effort applied is less. What is the use of this type of machine? If I am using this machine where I am applying less effort, load is more, so definitely the work is not going to be done. But if effort is less, okay, then what type of use you can do? Okay, so by applying lesser effort, if I am able to lift a greater load, it is acting as a force multiplier. Got it? So whenever the mechanical advantage is greater than 1, I can say that the machine can be put into use as a force multiplier. Okay, so all your jack, your spade, the pulleys, okay, where we are applying lesser effort but able to lift a greater load, we can say that we can use such machines. Okay, now this was the one case. Then we have another one. We have effort applied is more, load is less. So mechanical advantage is equal to load by effort. So load by effort, effort is greater, denominator is greater than the numerator. So as a result, mechanical advantage will be less than 1. Okay. So now here what does it mean? Load is less, effort applied is more. What it can do? It increases speed. Okay, as it increases speed, so this can be used as speed multiplier. Okay, so like we have scissors, we have blade of knife, they can be used as a speed multiplier. Okay, third case, your load is equal to effort. Whatever load we are applying applying the whatever effort we are applying, we are able to lift that much of load. So mechanical advantage L by E, which means that now here what we have, L is equal to E, so the L by E will be equal to 1. Alright, so load is same as effort, which means that there is no increase in the force, there is no increase in the speed. Then what use we can put this type of machine is put into the use, that is when the mechanical advantage is equal to 1, the machine is used to change the direction, to change the direction of effort. So now we have three cases. E less than L, MA will be greater than 1, the function is your force multiplier. E greater than L, MA less than 1, the function is the speed multiplier. And third, E equal to L, MA equal to 1, this will be to change the direction of effort. Okay, so this is why we try to calculate the mechanical advantage. So whenever you have to study about the machine, you should know the mechanical advantage of the machine, and then you can tell what use it can be put. Okay, I hope this is clear to all of you. If you have any question, you can ask related to this. Scientific definition machine introduces human effort, and in case of a speed multiplier and effort, it's not only that it has to decrease the human effort, but it is not necessary always that we have to decrease the effort only. There are various applications where we require that there should be change in the direction of application of the effort. There should be increase. Say for example, bicycle, if you are using, okay, for what purpose you are using the bicycle? You are using motor car. For what purpose you are using this motor car? Okay, so that you are able to gain some more speed. Okay, so decreasing the effort of the human being is not only the case applied here. Okay, it will have no unit. Very good, Yashita. But anybody can tell me why the mechanical advantage is not having its unit? Verifications. There are a lot of observations have been done, and then we conclude the come to the conclusion. Say for example, a principle becomes a principle only after it's positive as well as negative both end. The way it is there and in the opposite also, how it is behaving. Okay, that has been studied, and then it has been found out that okay, now this is going to be the correct one, because if it is the opposite direction, or if we are taking the negative of it, this is not going to come, or this is not giving us the correct information. Although experimental, see, there are two things. One is theoretical value, one is your experimental value. So whenever we are performing or we are verifying it, your experimental value should verify with the theoretical value. Now, for example, when you say that why not it is E by L, so it has been done a lot of time when mechanical advantage was calculated by L by E and E by L and then related to the various application. Okay, it was observed that E by L was not the right, it was L by E. Okay, so that is how it has been done. So I hope, Mayank, it is clear to all of you. Ashutosh, force multiplier effort is greater than load, it is a speed multiplier. Effort is greater than load, it is a speed multiplier, and effort is less than load, it is force multiplier. Effort is equal what type machine, it is force or speed. If effort is equal to load, then we are basically using that machine to change the direction of effort, neither force multiplier nor speed multiplier. Yes, we have practically, say for example, when we are using the pulley, okay, the example of the well where we are using a pulley, it is an example of your third case, that is change the direction of the effort. Load cannot be greater than effort, it can be. Okay, it's 50 kg you have to lift, your weight, you are able to apply only 40 kg, it can be greater. Devesh. Kana, right? Mechanical advantage is not having the unit because it is the ratio of the same quantity, load by effort. Load is also force and effort is also force, therefore they will not have any unit. Good. Ashutosh Ranjan, right? In 3. Yashita, correct. Lokik, right? Write down ratio of the same quantity.